Remember we defined the integral of power function x to power n, and note that n cannot be equal to -1. Otherwise, you get 0 at the denominator. We're going to discuss this case later. So the fundamental theorem of calculus part 2 says, well, if f is a continuous function, an interval whose interval a to b, then the integral, the definite integral a to b of function f dx must be equals to f of b minus f of a. What is this f? F is just any antiderivative of function f, where f is any antiderivative of f. What's the meaning of that? It means that if I take the derivative of f, it must be equals to the integrand, the function inside the integral. So in this case, in our formula up here, our f is equal to this quantity on the right-hand side, and the quantity inside the integral is your integrand or f. Let's take a look at the following example. Suppose I ask you to calculate the integral 0 to 2 of x squared dx. The very first step is to find this integral without using the boundaries. We need to find that f. What is f? Well, the f is defined here for us. Just note that n is equal to 2, right? F of x is equal to x to power 2 plus 1 divided by 2 plus 1 plus constant of integration, or x cubed divided by 3 plus c. But the fundamental theorem of calculus part 2 says, well, now just substitute the upper limit b into the function, substitute the lower limit into the function, and then do the subtraction. Well, what is f of b? F of b is f of 2. What is f of 2? F of 2 is 2 to the third divided by 3 plus c, or 8 thirds plus a constant of integration. What is f of a? You need to find f of a as well, right? F of a is f of 0. F of 0 is equal to 0 to the third divided by 3 plus a constant of integration, or 0 plus c. Now take a look at this. We're going to take these two and do the subtraction. We get 8 third plus constant of integration minus 0 plus constant of integration, or just c. So as you can see, the constant of integration, they disappear. The outcome is 8 over 3. What we actually did, we actually graphed this x cubed, the function x cubed, x-axis, y-axis. So here let us have 2 and have, for example, let's just have 1 here. And 2. I'm going to increase this. So suppose this is your 1 and then this is your 8, for example. So this is the graph of your function. and your x is bounded between 0 and 2. So you're actually calculating this area below the graph, which is equal to 8/3. Without using any Riemann sum, any limit, we use the shortcuts for nice functions, and we actually found the area below the curve when x is bounded between 0 and 2. But this is